Well, you guys are in trouble, and so am I, because apparently I wasn't streaming. So I had filmed for the past 2 hours just working on this project, and turned out nobody was actually seeing anything, and it was waiting for me to click a button to actually go live. So that's okay. We are fine. We are going to go ahead and just start over here. So I have a bunch already written, and we are just going to delete it. Hooray, we're starting over. And let's go ahead and set the repository up. Okay, so there's a link in the description, and that link is going to bring you to this Git repository here. Hop over to the working branch, and you will be able to see the latest changes as they're coming in. I will be making commits as I go. Let me go ahead and just clear out what we have and git add dot. And we're just going to say that git push public working. Nice and secure password. Okay, so you should be up to date now in the Git repository. And let me just go ahead and explain what we are going to actually be making today. So today we are making a peer-to-peer network. And a peer-to-peer network is a client-server model in which every node can act both as a client and a server at the same time. And so what we're going to want to do is to make this a multi-threaded object. Eventually, we're going to turn this into a component in the library here. You can see we have a lot of components already that we're going to be pulling from. But eventually, we're going to want to create a peer-to-peer model in our nodes here of the networking sublibrary. But for now, we're just going to stay in this test folder with this test function. And what we're going to need to do, well, we'll define our main function. And here we're going to first create the server itself. So we're going to do this with a thread. So we're going to call pthread-t, and we'll call this server thread. And then we're just going to launch this thread. So pthread create, we'll pass it server thread, and we're going to give it no attributes. And then we need an actual function for the server. So let's define our server function. This is going to be a void pointer is the return, not because I actually want to return anything, but our pthread create function is expecting a pointer to a function that returns a void pointer and accepts a void pointer as its argument. And so that's what we are going to need to actually give it. So our void pointer function is going to be called server function, and it's going to take a void pointer for an argument. So down here we can say server function and null as our argument. So that's going to create our thread here. But what is this thread actually going to do? Well, at the end, we will return null. Get rid of that error message. And what we want to do in this function is basically enter an infinite loop. So while true, we are going to just accept connections from clients and read the messages they send. This is going to be a chat system. So you will send a message and I'll be able to read it. Then I'll send a message and you'll be able to read it. Hopefully by the end of this, we could actually run these and you and I would be able to chat using the system. But we got some work to do before we get there. We need to actually create an instance of a server. Now I have this server as part of my C library here, but let's go over how it works. We're just going to call this server constructor. We'll pass it a few parameters. The domain is AFINet.6. Service is going to be sock stream. Protocol will be 0. NADDR any. We'll use 1248 and a backlog of 20. Okay. Some of these are arbitrary. I chose 1248 as the port just on a whim, and I chose 20 as a backlog. arbitrarily. But the rest of these are important, and we need to make sure we get them right. Now, there are many different options we can use here. So for instance, AF-INET you saw originally was AF-INET 6, and that is for IP version 6. Now I'm only doing version 4 at the moment, so that's why I'm using AF-INET. But it's circumstances like that where I don't know what the user wants their server to be using at that point, that I make them put a parameter into the constructor. So let's take a look at what this constructor is actually doing. We go over here, we can see where it is defined, but our actual usage of it is right here. Most of those what are these things called? Arguments, parameters. Most of those parameters are just saved into this server object. Some of them are derived though. So our server's address, for instance, has to do some manipulations in order to turn them to network bytes rather than their original data types. This is where things become important though, this server.socket. When we create the socket, this is actually allowing our system to access the network. And our socket is what does that. We pass the socket the domain, service, and protocol, and then we store the socket address as an integer. And that is served as part of the server object. We also want to test to make sure it actually connected. We want to bind that socket to the network, and then we want to start listening on that socket. Listening is where it's important. This is where it will accept our incoming connections. So we can start listening here, and the server constructor is just going to set all these parameters and then start doing these basic networking functions. So makes it simple over here. We just need to call the constructor, and all of that will be handled for us. But there are going to be a few things we'll need to do with some of those parameters, but I'll show you that in a second. First, let's set up our infinite loop. We can just say while 1. And while we're here, we're going to want to get the connection from a client. So we're going to say int client equals accept. And we're going to accept on the server dot, socket. And here we need to do some casting of the server's address. But rather than casting with every iteration of the while loop, I want to actually cast it outside of the while loop. That way I can do that operation once and I never have to do it again. So it'll save on some processing time to do it out here. So if we say struct sock_addr pointer, we'll call this address, and we'll set it to the casting of the address of, not socket, but server.address. And then we are going to have a socklen t, and we'll call this address length, and we'll do the same thing, socklen t, and we will do size of server.address. So down here we can pass in address and the address of address length. That will create our client, or it'll accept our client. So when our client connects and asks for something, then we are going to actually accept what they have asked of us. And once they have given us, or once we have accepted that connection, we need to store their request. So we're going to create a character array called request, and we're going to specify that it has 255 characters. The number is chosen fairly arbitrarily, but I mean, we could make it whatever we want, but 255 seems like a nice number for a chat bot or a peer-to-peer network specializing in chat. 255 characters. I think that's what Twitter uses. So that's what we'll use here. Anyway, what we want to do next is actually use memset. And for that, we're going to need the string library. And memset is going to set in request every character to 0. Why would we want to do this? Well, if we think about what happens with the stack, So all of these variables are saved on the stack in the scope of this while loop. So when we hit the while loop, let's imagine our stack pointer is right here. First, it's going to create a client, and that's an integer, and that's going to be 4 bytes. So we're going to move the stack pointer 4 bytes. Then we create our request, which is going to be 255 bytes. So we'll move it up here. And then let's imagine we did not do the mem set. So let's say that's left out. Let's say we write something to the string, and it's, let's say, 200 characters long, and then we exit the loop. Well, when we exit the loop, all of this goes out of scope. What that means is that we're just going to move the stack pointer back down. We're not actually going to zero out anything that's in there. We're just moving the stack pointer back down. So what happens when we get the next iteration of the loop is that we define int client again, and we define request again. And these are actually going to end up taking up the same spaces in memory because we're just moving the stack pointer again in the same outer scope. And what would happen is that the character array request may still have some data in it, and that can give us some strange results. So we want to make sure that we have emptied out this request character array before we actually do anything with it. That way we know that we're working with a clean entry point. What we do want to do with it, though, is write to it. So we're going to call write, and for this we need unistandard. So we will write to, well, from client, we're going to write request, and we have 255 characters. And then we can simply print it out to the screen. There we go. We'll finally close the client connection. And that is our infinite loop for the server function. Did I do this wrong? Oh, I need the standard in and out. Okay. So this loop is basically going to accept an incoming connection, save what that connection sends it in this request string, and then it will print out that request to the string and then close the connection and await the next one. So that is the function that we are passing into our thread. And then we are left with the client side of this. So the client is going to need to basically take the user's input and send it to a server as a string. So let's set up a client function. So we'll have this one as just a void. It'll return nothing. We'll call this client function. And it will take a character array or a character pointer called request as its argument. And what we're going to do is create a client. So struct client. 3 of us here right now. Welcome, everybody. Glad you're here. Feel free to say stuff in the chat if you are particularly angry with the way I'm doing something. We're going to use our client constructor. And this is going to take the same parameters as our server constructor. And don't worry, I will go into this client in just a moment. But again, some of these I can say are arbitrary. So like our 1, 2, 4, 8 and our, well, that's not arbitrary, but our port here is arbitrary. The rest of them make a difference, but I don't know in every circumstance what someone's going to use. So you have to pass those in as parameters. So our domain is going to be AFINet, not 6, but I'll just leave it for now. Service will be SockStream. And I'm just deciding to make these exactly the same as that of the server for simplicity. And that will just kind of guarantee that I won't run into any problems through choosing the domain or the service or anything like that. So let's take a look at this client for a moment. Here, it's very similar to the server. We have a bunch of parameters that we just save as members in the client object, and then we are going to create a socket. And we also have a member method here called request. And this is going to basically make the request to a server for us. We have to pass it the server's IP address and a character pointer to the request itself. So our server function, we create an instance of one of these clients, and then we are going to send a message. Client, not in caps, client.request, pass it the address of client, and we're going to pass it request. But we also need to send it the server's IP address. We don't know what that is just yet. Kind of. I know what it's going to be. We're just going to use my loopback address for now. In the future, what we'll probably end up doing is if we actually want to use this as a peer-to-peer chat network where other people can join, is make this, instead of a loopback address, something like an access point. So I could own a domain name that you could use to actually get access to the network. And then once you're on the network, you can get a much more robust list of people to connect to. But for now, we are just going to use my loopback address as that. And I don't know if you guys are seeing this. Things are kind of going crazy. Not sure what the problem is. It looks kind of weird on my end. I don't know if you guys are seeing anything particularly odd. Seems the stream has been cut out. Going on here. I'm sorry for the technical difficulties. Just trying to make sure that nothing is going particularly wrong. My system is almost completely frozen. Ooh-wee. I'm not sure if I'm even still broadcasting at the moment. Well, if you're still here, you're a trooper. I appreciate it. I don't know if I am broadcasting or if I'm just talking to myself here in my room. Okay, I'm going to take a quick water break in case you can still hear me. And hopefully it'll be working when I come back. Let's see. Quick water break. Okay, no luck. Can't do anything, so I'm going to have to shut down and okay. I think we are coming back here. Well, it's a shame that that cut out. I'm sorry about all that, but I don't know what went wrong there. It just seemed to kind of all crash at once. And so let's just jump back into where we were. I've lost all the viewers at this point, but that's to be expected with such a catastrophic crash. That's all right. Let's see where we left off. Okay. So we've created our thread, our server thread, and now we're working on the client. So we send this client the IP address, and for now we're just using loopback. So we need a way to actually get what the person running the program is asking for. One of you has come back. I appreciate that. Thank you very much. I'm sorry about the cutout. It was quite catastrophic on my end. I had to actually hold the power button and shut everything down. No idea what went wrong there, but today has been quite an event of unfortunate things happening. So appreciate you being patient with me there. Anyway, so now we need a loop to actually get what the client is asking for or send that message. So we're going to enter another infinite loop, and this one is going to be in the main function. So this is where the user is going to be able to give an input and send that to the other nodes on the network. So while one, we are going to create a character buffer. What are we going to call it? Request. And we'll set it to 255 characters. We'll again use memset of request. We're going to set that to 0. And the size is also going to be 255. So again, we are going to want to clear out this string every time. That way we don't send information that was in the previous one that we don't want to send again. Weird stuff can happen with this. So we want to actually manually clear out request. Excuse me. So we can now use fget_s, and we are going to put in request. Int is going to be 255. That's how many we can, and we're going to take it from standard in. So this is actually going to take the user's input and store it in request. We know that it can be 255 characters, and it's coming from the standard in. Once we actually get it, we're going to call the client function, and we are going to send it request, or the address of request. Request is an array, so the actual variable request is just a pointer to the first element in this array. So we can send that here, and it functions as a character pointer up here. So we have our request, we have made our request, and this should actually be working as is. So if I run it, 2 of you are back. Welcome. Glad you're here. We're running it. I'm not getting the terminal up. All right, so. Oh, I'm sorry. It's building the wrong thing. Put that in, address of server thread. And I'm probably going to need to turn off the face cam because I'm losing battery. And so we have to do. So I'm going to pull the face cam now. I'm just going to plug in the Mac so that I can charge and keep going here. Okay. So here's our terminal. And if I type in hello, it does not print our hello back. So let's add a few print statements in here so we can see what's happening. And we're going to print here. That it's starting the server. And then in the server thread, let's actually print server running. And that should be good. Let's actually put a break statement or a breakpoint there so we can see what happens. Okay, server is running. Okay. The request says nothing. Okay. Because I'm using write instead of read. Okay, so our server function, instead of write, needs read. Takes the same parameters. So now if we run it, I'm probably going to have to wait a moment because, oh no, it worked right away. So if I send hello, I get hello back. Hi, how are you? I get that back. But that's not super convincing because it's just printing what I wrote back. Let's have it change things a little bit. So instead of just printing this, let's print 3 tabs. And then that person says, and we want to call a function here. I want to print out the IP address of the client. So I'm going to include ARPA/inet. This will give me a function called, what is it? inet a to n. And I want to just pass it one parameter here. And that is going to be, what is it going to be? I'm forgetting. I have it in my test project. Server address sign ADDR. Server.address.sign ADDR. So the server's address will actually end up storing the client's address when we actually use this accept function. So the client's IP address will be in this parameter of the server. So we can actually get it out. And I've done this wrong. inet ATON, NTOA, not ATON, other one. So this will allow us to insert our, we need a comma, sorry. This will allow us to actually insert the client's IP address into the statement. So it'll insert that as a string, it'll say that they say, and then it'll say what they say. If we run it now I say hello, and 127.0.0.1 says hello. I say, how are you? They just repeat it back. And it's not very convincing at this point because it's just repeating back what I said. But I could, in theory, have another system running that is also running this exact same program. And in fact, you could have this system running this exact same program. And so long as we knew each other's IP addresses here, we would be able to communicate with this chat protocol. But this isn't very good. And the reason that it's not very good is that we have to know this going in, and we're all going to be communicating with the same central server, which is kind of defeating the idea of a peer-to-peer system. So what we actually want is a list of known addresses, and we can get that list. So what we're going to do is create a linked list. So struct linked list, and we'll call this known hosts, and we'll call the linked list constructor. Now, my linked list implementation is a little bit unique. So I have it in data structures, lists, linked list. So it has a few member functions for inserting, removing, and retrieving, and those are really the functions that I'm concerned with, and its length. The back end of this will handle most of the work for me. So I store everything in these node objects. We can see that node here. And the node has a void pointer to its data. This allows me to store anything I want to in it. So I can store integers, I could store strings, I could store anything, structs, anything. And the linked list itself doesn't really care what I'm putting in those nodes. So I can store anything I want in the same kind of linked list. I just have to remember to cast it back whenever I retrieve it. So we're going to use this linked list constructor, and then we're going to say known hosts.insert, and we need to insert a few things into it. We need to pass this a reference to the linked list itself. This is like passing self if you've ever used Python classes. Then we need to pass it a integer, and that is the position in the list in which we want to insert something. Then we pass a void pointer to the data and the size of that data. So we are going to insert the address of known hosts. We want to put this in position 0. This will be the head. And then we want to insert 127.0.0.1 as our known host, our first one. That's going to be our access point. In the future, this could take the form of having a known entry point. So if I own a domain name, then I can point this domain name toward our chat network, and whenever you're ready to enter the chat, it will just use that as its access point and then share a list of known hosts with you. That's how we'll get a peer-to-peer model out of this. But anyway, let's continue. We also want to pass it the size of this character array. Now, I can look at this and say that it is 9 bytes because there are 9 characters in this array. Well, actually, there's technically 10 because of the null termination of this. So after this, we basically have \0, which in code is actually, in binary, it's literally 0. But this has 10 characters in it if you include that null termination. I have had problems with this sort of method in the past where if I pass in a string literal and the size of that string literal like this, then I'll often end up with some errors, but let's just see if that actually happens, and if it does, we'll go from there. Okay, so now that we have created a list of known hosts, we can send that list to our server function, and our server function takes a void pointer, so we can actually send it our linked list. So instead of passing null here to our pthread create function, we're going to pass in the address of known hosts. This will be a null pointer up or a void pointer up here. So the first thing we can do is actually cast it back. So this is a, what was it again? A linked list. Struct linked list pointer known hosts equals arg. And this will implicitly cast our void pointer back to a linked list. And once we do that, we can come down here and see if this address is in our linked list. So I know I'm going to need to do this multiple times. So to save on iteration, we're going to create a variable here. We're going to call this character pointer client address equals that. And we'll just printf the client address. So now we want to see if the client is in our list. So we'll do this after we close the client. This will free the client up to do other things, whatever it wants. So we've created our client, we've gotten his address, and so now we want to check the list. So we are going to have to iterate through the list, and my linked list function or implementation does not have a search function, so we have to do that manually. So for int I equals 0, I is less than known hosts.length I plus plus, and I can't use the dot there since known hosts is a pointer. Use the arrow. We're going to go through every single item in the list, and then we're going to try and compare them. So we're going to create a variable here called short found. I would use a Boolean for this, but I don't have Boolean installed as or included as a library. Excuse me, I need to clear my throat. To cough right into the microphone there. Anyway, I'm just going to use a short here. It takes the same number of bytes as a Boolean. It's easy enough. So we want to do this until we find it. So while I is less than the length of known hosts, and it's not found. So while found equals 0, we are going to compare the next item in the list to the thing that we found up here, the client address. So if string compare client address and known hosts dot arrow retrieve address of known hosts and I. So the retrieve function is going to take, we don't need the address of here because it's already a pointer. We have to pass in the known hosts list itself to the function. This is us passing self into a function. And then we just pass it which item we want to retrieve. And we want to retrieve them one at a time. And this parameter here of string compare is supposed to be a character pointer. So again, we are implicitly casting the void pointer that retrieve will send us as a character pointer. And if that comparison equals 0, then we're simply going to say that it has been found by setting found to 1. And once we are done with that loop, we can say if not found, we are just going to insert it. So known hosts insert, we are going to insert it into known hosts. The position is going to be the end of it, so known hosts length. What we are going to insert is client address. And we are going to insert it, well, the size of it is going to be size of client now. This is where I have often run into problems when I use the size of a variable to the actual string. I often will run into problems with that, so I'm expecting to see that here when we run it, but we're going to leave it for now and cross that bridge once we get there. There's another function we can use this client address in, and it's right here. Instead of sending it this function, well, instead of sending this function just this request, we can send them address of known hosts as well. We can add that in here. And this will allow us to access the list of known hosts in this function. Excuse me. If you didn't catch the beginning of this, I thought I was streaming for 2 hours before I started, so my voice is kind of losing it, but that's okay. Anyway, what we are going to do, instead of just sending it to this one access point, we're going to do a for loop. Int I equals 0, I is less than known hosts length, I++. And in this loop, we're going to make the request each time. Instead of passing in this string literal, we could say known hosts retrieve passing it the address of known hosts, it's already a pointer, and I. So now it'll send it to everybody it knows. So if we have multiple people on the network, if I send a message out and I know everybody's IP address, I'll send it to every single one of them one at a time. And so that is our plan. So let's run this, see how it does. Server is running. I say hello. They say hello back. Now, if this is actually working, when I ask how are you, I should only get one response. There it is. So if I stop this first, if I put a breakpoint in here, I'm going to put it right. Let's put it right here. What I want to see is that whenever I make a request to the client, then I am just going to stop and be able to see if this is actually retrieving it. I wish I had seen this here. So what I'm going to do is actually put that there, that there. That way we can see if it actually is finding it. So let's run it again. I might have to wait a second. Yeah, I have to wait till it's no longer in use. So it's going to just take a minute. What I'm trying to surmise here is that it is, in fact, seeing the correct IP address and seeing that it just happens to already be in the list. So let's run it. There we go. Hello. Stops there. Client address. That is correct. Found equals 1. So yes, it is. So it did, in fact, find it. So it's not going to add it. Perfect. And then I can say it again. How are you? Client address. Found equals 1. Perfect. So this is working great. Now, it's great that I have a list of the client addresses, but it would be nice if I could send my list of client addresses to other people on the network. So instead of my request always routing through this single server function, it would be nice if I could have it actually select a function to run. Is it trying to send me a message, or is it asking me for all of my known hosts? That way, if person A and person B are on the network and they know of each other, and then person C comes and talks to person B will tell him about person A, and that will allow us to more quickly grow the network and get many more people connected to it at once. You also end up with sort of an exponential growth where as one person joins, more people find out about them more quickly. So how are we going to do that? Well, we're going to need some interesting things here. So on our client side, we're going to need a function for actually requesting that specifically. So instead of just sending whatever the user types in here, we're going to need to actually format this in a specific way and parse it in a specific way. And I have not done any experiments with that yet, so I think we are going to leave that for another time. What I do want to do is add a little bit more functionality to this server. So at the moment, the server is just a single server. And if 100 people are trying to contact it at once for different things, it's not going to be particularly effective. So what we actually want is to make it multi-threaded. And we have the ability to do that in the library. I have this thread pool created. The thread pool is basically an object that will make this really easy to do. We essentially will pass in the number of threads we want, so 5, 6, 7, however many we need. It will then have a queue of work, so anytime we have a new job for it to do, and it has a few mutex locks to make that pool thread safe, but basically we just need to call this add work function. So let's go back over to our main, and let's make this a multi-threaded server. So after we print the server is running and we cast linked list, we create our server object, and we cast those two things. It's this infinite loop that I want. I want to make that my additional function. So we're going to call void pointer server loop, void pointer arg, and let's just paste our loop into there. Now we're going to get a bunch of errors here, but that's okay. What we want to do is actually create a thread pool in the server function. So struct thread pool, call this uncreatively, we'll call it thread pool, and we'll call the constructor. Now, why would we want to use a thread pool here? So I could just, every time someone connects, I could just create a new thread like I did here, pthread t server thread, pthread create. I could just create a new thread. But what I really want is to specify how many threads we're allowed to have. So if I only want there to be a maximum of 50 threads, that's why I would use a thread pool. It dedicates a certain number of threads to the system, whereas just creating them as they come in runs the risk of actually overloading things. And you would end up creating as many threads as there were clients, and that can actually be slower than not being multi-threaded in the first place. So we're going to create this thread pool, and then when a connection comes in, we are actually going to send it to this. So we're going to need a while loop. It will be an infinite loop. We're just going to accept. So int client equals accept, passing it server.socket address, the address of address line. So we don't need to do that here. But we do need this here. And we seem to need to pass a few things into this server loop. So I'm going to create a struct called server, capitals, server loop argument. Here we are going to put a struct server pointer server because we need the server. We also need the client address. So we'll put int client. And do we need anything else here? Oh, we need the linked list. So struct linked list pointer known hosts. And we need a semicolon at the end. So here we are going to actually create an instance of this argument. Struct server loop argument, call it arg. And we are going to say arg.client. Client. It's a little bit more efficient of a way to do this, actually. So I'm going to cut that from there, paste it there, and just say arg.client accept. And then arg.server equals the address of our server, and arg.knownHosts equals arg. We could also just say known hosts because we do it here. Actually don't really need to do it there, and it's going to be a void pointer anyway, so let's just pass arg in there. What does it not like about that? Incompatible type. Server loop argument. Do I need to? Oh, I see. Doesn't like that I'm calling this arg. Call it loop arg. I already passed in arg up here, so I was copying it over down there, and that was causing a problem. Anyway, so we've created this argument, and now we can actually put it into the thread pool as a thread job. So our thread job is a little bit different. We take a void pointer to the function that we're going to run and a void pointer to the argument. And this gets inserted into the work queue. Our work queue allows us to keep our jobs in order, and it also makes it thread safe. So we use these parameters here to make things thread safe, and we can just use this add work function to add jobs to the thread pool. And the thread pool and its implementation knows how to handle these. It calls this generic thread function, which will just pull the thread job struct out and execute its job, which is the function that we pass. So where do we need to go? And what do we do here? Okay, so we've created this argument for this server loop. So now we are going to create, say, thread pool, not constructor, thread pool dot add work, passing it the address of thread pool. Again, not constructor. We're going to pass it what we are inserting into it, which is a thread job. So we need to actually create this as a thread job first. So struct thread job, call this server job equals thread job constructor. Here we just pass it the function that we want and the argument that we are passing into it. The function is going to be server loop, and the argument is going to be loop arg. And then down here we can add server job. So this is our new server function. What did it not like here? We want the address of that. Okay, so this is our new server function. It enters an infinite loop still, And the accept section is done here, but it actually will combine all of these into one item, and that item becomes the argument for a server loop. And then we just add that work to the queue and move on to the next client. So we can just keep accepting clients and tossing them into this pool. So let's go to our server loop. And server loop actually doesn't make much sense as a name because we're no longer going to be doing this in an infinite loop, but that's beyond the point. We're going to create a character request of size 255. We'll use our mem set. Set it to 0. 255 characters. We're going to read. We need to actually cast our argument. So server loop argument pointer. We'll call this argument equals arg. And that's going to implicitly cast it for us. So now we can say read argument client. And we're going to read that into a request. Size is, what do we want as the size? 255. Okay. So now let's get our client address out. And here we need to do argument server. We're just changing some of these things so that we are referencing the correct object. Yeah, that's right. Server is a pointer inside of the argument struct. So we will grab the client's IP address. Then we want to print out what they say to the screen and close that connection. And then we want to test if the item is in our list. So we want to do argument, right? The argument's clients. We'll set found arguments known hosts singular. Got to insert that. Okay, I think that should be good. Now delete this. Oh, we're missing something there, actually. Yeah, that we need the if found. And almost there. We return null at the end. Okay. That should be working. So now our server should be multi-threaded, and we should be using a thread pool for it. So if I launch this, really shouldn't look any different. It should just keep working. But each of these little actions is being handled by an individual thread in this pool. So if 1,000 people, well, I set it so that it has what? How many threads were in this thread pool? 10, 20, something like that. Where is it? 50. I set it up, so 50. So if 50 people were to ping this server all at exactly the same time, they would all have to wait one at a time for this accept function. But basically, we're just going to accept it and then pass that on to another thread. So in the time it takes us to just accept the client, we are already ready to move on to the next client. We just pass this off to a different thread. So this should all be working right now. And what we need to do now is to kind of take a step back and look at what we've created and find a way to generalize it. So this is sort of the way object-oriented programming works. You know the end goal of what you're trying to make, So you make it, and then you find all the ways that you can generalize it. And so what we want to do is to generalize all of this into a single peer-to-peer object. Before we do that, let me go ahead and commit this to the Git so that if you are following along with the code, once again, that link is in the description, you can see the most recent updates. So git add dot add a message. Multi-threaded have 2 Ds. We're going to say it has 1. Created a multi-threaded. Okay, so that should be available for you now. If you go to the GitHub, you can see all of the code there. And let's also put it to my personal. So let's now extract this and turn it into a single object. So the code is now available on GitHub. You can see this in its most recent incarnation. And what we're going to do is try and abstract this into a single object that we can add in here. Let's go ahead and create that file. We're going to call this peer-to-peer. And let's start in the .h file. So this is going to need to create a struct called peer-to-peer. And what are the parameters that we have in this peer-to-peer object? What does it seem to have? Well, we have a linked list of known hosts. That will be useful. And then we have a client and server object. Now, the client object, we recreate every single time. So I don't know if we actually want to define that as a member of this thing, this peer-to-peer object. And we also have a server. Now, the server we create once, and it exists forever. So I think that makes sense to add as a member in peer-to-peer. How's the battery doing? Can I? Nope, not yet. I'll plug in the face cam again in just a few minutes once my battery is back more. Anyway, so let's create a few items in here. Let's pull main.c next door, and that way we can see what we have. Okay. So we have a struct server. We'll call it server. We also have a struct linked list. And this is called known hosts. Then we have these parameters like the domain, the service, protocol, port, interface, those usual things. So let's put those in as well. So int domain, int service, int protocol, int port, unsigned long, interface. What else do we need? Is that it? I think that might be it. If we need more, I'll figure it out later. Anyway, it's also not giving me autocorrect here, so I'm going to switch this to this and build it. That's not going to work because I don't have those things included. So let's include them. Now, if you are ever using my library, this is not the way that you should be including things. You should be including things like this, or actually more specifically, that's what your include should look like, using my library. But I'm working within the library right now, and I want things to be a little bit more specific. So I'm going to use the exact path to what I'm looking for. I need server.h. I need data structures, list/list.h. Be those. Let's build it, see what it says. All right, it likes that for now. And we're going to have a constructor in here. So this will be construct peer-to-peer. And we'll have a constructor. We are going to pass it all of those same parameters. Main, service, protocol, port, interface. We're not going to define it here. That's basically going to create our object for us. Doesn't like it. What does it not like? Oh, I don't need to type that. But I want that. Okay. There we go. Great. So let's hop over to the .c file and actually define it. So let's put this over here. And here. Switch to that. Okay. So our constructor. Let's just copy and paste it over for now. So we don't have to type all that in again. And what I'm going to do is simply define peer-to-peer. And then we'll return that at the end. And in between, we just need to instantiate a few things. So peer-to-peer.domain, domain. Same thing with service and protocol and all those. Great. Now, we want to actually start doing things. And the hard part to generalize is what they are going to do. So I can say with relative certainty what this peer-to-peer that we've created over in main is doing. It is a chat client. It sends a message, server accepts messages. But I don't think we really know what every instance of a peer-to-peer network is going to want to do. So I think we are going to be better off if we make it a little bit more generic so that maybe the user will specify the function that these things are going to run in the actual constructor. So let's take a look here. We have our main thread here, and kind of the common denominator I'm seeing is these infinite loops. We kind of enter two infinite loops. One of them happens here in main, other one happens in a thread. So let's create a user portal. We're going to call void user portal. Pass it. Let's make this a member of peer-to-peer. Pointer to a function called user portal. Takes no argument. And we'll set that function there. And what's this function going to do? Well, this is going to take the place of main right here. So, or right here, that is. So it's going to be similar basically up until the while loop. So we can say void user portal. And here we are going to create a character request 255 characters. Do a memset on it. What happened here? What did I do? Again, to clear it out. Gets. And this is going to require this standard IO library. And the string library. Great. And then this user portal is going to create our thread for the server. So pthread t server. Correct? And then pthread gate. Oh, I need to include threading. Okay. And we'll pass this the address of server thread. No attributes. Always does that. And our function is undefined right now. That's okay. So, in fact, I'm not sure all of this is even what I want to do. So, what I'm thinking instead, user portal should take a reference to a peer-to-peer object. And we should define what the server function and the client function is externally. So here we will have the user pass in a void pointer returning function called server function that takes void pointer argument. And we'll want another one of these for the client. And we'll call this one client function. And we're going to need to copy all of this over to our .h file. Okay. Now, the reason for this is that we can allow the user to define these themselves. So whatever they want their peer-to-peer network to do, whatever they want a client to do and whatever they want the server to do, they can just define that in their own functions, pass that in to the constructor, and it should work. But we just need to instantiate them here. So we have a user portal, but we also have a void pointer returning pointer function called server function, and we have a client function. Okay, so those are those two, and then we can just set them here. Peer-to-peer dot server function, server function, and peer-to-peer dot client function, client function. Then down here, what we'll do is actually, for our thread, we're going to call peer-to-peer, nope, server function. We'll pass it null for now. We'll probably want to add functionality for someone to, pass in the argument for these functions. But for now, we're just going to assume that there's no argument. We can come back to that in in it. And it doesn't like user portal because it's taking this now. So that as okay. And there we go. Okay. So we can refer back to this server function. Whatever the user defines their server function to be, we can just stick that in and say, run this. And that should have an infinite loop in it. And then they should enter an infinite loop for their client function. So we can say peer-to-peer dot client function. We actually need arrow axis. And we'll just pass it null as its parameter. And that should be fairly sufficient for our object. If we come back over to our main function, we can kind of redefine this so that it will use our peer-to-peer object. Let's close out of these for now. And try over here. How am I doing on battery? 38%. Okay. So networking nodes peer-to-peer.h. Okay. We include that. And how are we going to do this? Well, we're just going to... Oh, hold on. There's something we almost forgot. Peer-to-peer.c. We need to initialize that linked list. So peer-to-peer dot known hosts equals linked list constructor. And then we want to actually insert our access point in here. Now, we might not do this, or we might make the access point a parameter up here, but for now, let's just hard code it in to make it easy. And how did we do that? Let's just copy and paste it to save a second. There we go. I'm going to insert it into that linked list. Specify. Okay, so now we insert that. That work? That should be good. Okay. So we no longer have to do this, and we no longer have to do this, and don't need that. What we do need is peer-to-peer struct, call it P2P, call the peer-to-peer constructor. Domain is going to be AFINET. Service will be SockStream protocol 0.1248. Interface. What is our interface? Any server function and client function we have not defined yet. Let's clean out this infinite loop. Okay. So our server function in this case is pretty much going to be the same. But it can't be because of the way I've made it here. Okay. We're going to lose the multi-threading on the server for a brief period of time, but that's okay. Void pointer. Void pointer argument. And what we're going to do is basically the entirety of our system here. Let's call it new server function. And here we are going to take this in the loop. Okay, we needed to do some work. I kind of wish I hadn't added that multi-threading now. It would be a lot easier, but okay. Okay. We don't need that. We accept this. And we're not doing any of that. Okay, so we accept. Create our request. Use memset. Read the client. Server. Dot address. Now, where am I going to get known hosts from? Suppose if the argument that I'm passing in peer-to-peer is the peer-to-peer. So if we pass in address of, then we can access it here. So we know our argument in this server function is going to be the peer-to-peer network itself. So we can access anything that exists on it. So instead of calling this, we can say arg. Well, first we need to cast it. So struct peer-to-peer p equals arg. And let's just set this as a pointer to get some implicit casting here. So we can say p2p domain. This will allow us to define things once and not do it again. Service. Protocol. That interface. Port. We don't specify a backlog yet, so we'll do that later. I see there's 3 people here now. Welcome. Glad you're all here. If you have any questions, feel free to leave them in the chat. And my video will be back for my face in a moment once I am around 50% battery. We're almost there. We'll do a Q&A at the end of this as well. And the code is available in GitHub. Check the description. Anyway. So we can use the parameters of P2P to actually define these things. That way we don't need to do it again, and we can ensure that this server will be in alignment with what was specified in the parameterization of peer-to-peer. So we do that, and then we do some things to cast its address, which we do outside of the loop, which is always good, and we are no longer going to use a thread pool. So infinite loop time. So it creates a client by accepting that. We read from the client. We get the client's address, and we print what they said. And then we are going to check known hosts. Here's where we're going to get it. P2P known hosts. I'm going to need that all over the place. Okay. That should do it. So now we can move all of that stuff. And, whoops, I think I put that all in the wrong place, didn't I? Yep, that's okay. Let's just do that again. Thought it looked weird. Okay, so we have cast P2P and copy and paste. That's going to take too long to type again. Okay, get that there. And we need, instead of just that, we need P2P server. And Because if you remember in my peer-to-peer object, I have a server stored in it, and I want to use that server as my access point for all of these parameters. So we get our socket, address length. We don't need this. Don't need these. Find that as an int. No longer using threads. Okay, so now what we do is all of this. Okay, so we get our client, we accept them, we read their request using all of these, we then get their address, we print what they said, we close the client, we search the linked list. That looks good. See if it's there. If not, we add it. Client function. Okay, our client function is pretty easy. Let's delete this. And we can just call this server function. Okay, so our server function goes here. We can delete that argument. We're almost home. We are almost at the final product here. I think that this thing is looking pretty good. Okay. So our client function is going to take a request and the linked list of known hosts. So after we have gone into main, that's what we want to go into. But we want to make this a little bit more robust. We want to do this in an infinite loop for one thing. That way the user can continuously give input to it. Okay. And we are going to create this client, but, well, first of all, we need to make this a void pointer. And this argument. Okay. So let's go ahead and cast our argument. It's probably going to be peer-to-peer again. So struct peer-to-peer pointer p2p equals arg. That gives us our implicit casting back to a peer-to-peer struct. And then while true, we are going to enter this loop. So we can define all of these based on peer-to-peer. Main. Service. Protocol. Port. Okay. We define those. And we're going to enter our infinite loop. And we're going to need to get a message from the user. So we're going to define a character request, 255 characters long. We'll use memset again to make sure that this is nice and clean when we try and do stuff with it. We're going to set everything to 0, 255 bytes. And then we are going to fget s into request, 255 characters. File is going to be standard in. Okay. And then we just make a request to our client for every single host in known hosts. But we need to get this from P. I'm just changing these around so that they fit with my new way of getting access to this. So passed in as a void pointer, which is cast to a peer-to-peer pointer. So I need to say the address of peer-to-peer known host here. Peer-to-peer known host here. Okay. Is that everything? I think that might be everything we need, except for the fact that we need to pass in the client function. Okay. Now, our client function also needs to take, we're going to pass it the reference to peer-to-peer. Okay, so our client function actually ends up just being stored in the peer-to-peer object. And we've created a thread where we pass in the peer-to-peer to the server function. But in the user portal, we're actually just going to call the function and pass it peer-to-peer directly. And this is where the user is going to be interacting with things. So in this case, I have made it such that we create a peer-to-peer object, we pass it this client function, and our client function, in fact, you don't need to think about this as a client function so much as you would want to think of it as the user's portal. So maybe our peer-to-peer network gives us the option to enter some command line arguments or run some other thing or whatever it wants us to do. It's going to do that through our user portal. And the user portal is what we're going to call in order to activate everything. So down here, we will say p2p.user portal. Is that correct? And it needs to take a reference to it. So we call this user portal, and it just so happens that we decided that the user portal is, in this case, going to call the client function. And here we would instead probably make it do something a little more robust. But for now, let's just see how this goes. So if I build test, oh yeah, we got some bugs. Let's just go through and fix these real quick. They really need an option to just fix all. Just some slight problems with me using the arrow. Doesn't know what user portal is. Appear.al. It should know what that is. Oh. Okay. Bad file descriptor. Failed to bind socket. Okay. Where did that happen? That would have happened in the server. Bad file descriptor. Okay. Is it happening here? Socket, it's not actually. Protocol should be 0. That's not right. Okay. Why is it doing that? Maybe I'm sending it at the wrong place. So. Server constructor takes domain service protocol. Interface port backlog. Main service protocol. Main service protocol. Interface port backlog. Port interface. Oh. Interface port backlog. Interface port backlog. Okay. The things we're sending it are correct. Unless I didn't save them right over in peer-to-peer. Main service protocol, port interface. Protocol should be 0. Gotta clean this up a bit. This is getting a bit messy. Okay, so we pass it in order. Domain, service, protocol. Main, service, protocol. See, protocol should be 0. Port, interface, for function, client function. Why does it not work? Haven't changed anything. See, I was filming this for about 2 hours before I started filming. I thought it was streaming, but it wasn't. And I was running into a problem kind of similar to this, where it was just suddenly behaving different. So that's all right. We'll keep rolling here. That's interesting. -1 is the socket. Bad file descriptor. I'm really not sure what that problem is. Why it suddenly doesn't like these parameters. Where am I calling this server constructor? Both places. Yeah, there. Okay. Look at P2P here. Protocol is some crazy number again. Okay, give me a moment here. I need to take a quick break. Okay, we're back. Sorry for the delay. So, you're trying to figure out why our port has such a, or our, which one is it? Interface has a strange number. We have P2P. Protocol. Protocol has a strange number. And why does it have a what I'm going to do, well, I know protocol should be 0, right? Protocol should be 0. Instead, it's this. Why is it that? All right, let's stop that. And I don't think this will change it, but sometimes casting explicitly is what you want. Let's get rid of all of our breakpoints. That did not do it. Am I calling the server constructor in the correct order? Let's take a look at the server domain service protocol interface. Domain service protocol. Then peer-to-peer protocol. Interesting. I don't know why this isn't protocol equals protocol. Stop it there. See, it's 0 right there. So it's 0 when we put it in there. We return it. Where do we return it? Okay, let's stop it right there. Protocol should be 0. And you know what? I'm going to stop it right here too. Protocol equals 0. P2P. Protocol equals 0. So now we're going to enter this server function. And protocol equals 0. Stop here. P2P. Ah, see? Right there. Suddenly, it has changed. And why has it changed? It has to be in the way that we are passing this. So, calling it here. Maybe it's actually changed right there too. Okay, hold on. Go to the user portal real quick. Or maybe it's this somewhere in here. Okay, so we set it to 0. Okay. Peer-to-peer. Protocol equals 0 right here. So sending it into this thread, it's still 0. And we're passing it the address. Ah, I see. So look at this. Okay. So I pass peer-to-peer as a pointer here. And then I pass the address of peer-to-peer here. I don't need the address of peer-to-peer. I just need peer-to-peer. peer-to-peer is already a pointer. It's already an address. So that should fix it. So let's delete all these breakpoints, run it. Ooh, and we are constantly sending messages. Okay. Not really waiting for my input there. Okay, well, at least we're getting something. So we're almost home. Let's go back to main, client function. And it should be stopping right here. Ah, okay. This go here. So I had this part, this reading the input within this for loop, and so it wasn't waiting for it, and it was also trying to get a new message for every client that it would be sending it to. So if we try this, we might need to wait a second in between. Maybe not. Nope. Can't even put it in some input. Okay. %. Let's get this working, and then I'll turn on the camera. And there's only one of you here right now, so well, I guess we'll do some Q&A, but it'll just be us. So anyway, so if I do a printf here. Doesn't even print that. Interesting. I wonder if it just finishes this, kind of dies. Let's see if I, in the user portal, let's say I take the client function, I define it there. Instead of doing this, get rid of that one. Ooh. Here I'm going to need to do those two includes, or this one. Oh, no, I shouldn't actually. Include client.h and server.h. Nope, still doesn't like it. P2P again. Whoops. Okay. Okay. Yeah, we're still sending an infinite number of things. Okay. We're getting there. We are getting there. Let's see. Ooh. Even wait. Okay. Maybe it's a problem with the server function. Yeah, it's not even getting anything here. And it just keeps running it. See? IP address is zeros. Okay. So something strange is now occurring, which is great. This is interesting. That. Ah. There we go. That might be part of the problem. Just want to see if I can get it to print out the correct IP. No, I can't. Okay. So, something wrong with P2P? Looks good. Here we have some problems. Okay. Okay, so something has gone awry, and see, when we get down here, so what happens is the peer-to-peer constructor calls the server constructor, doesn't it? Doesn't it? Hold on. Does it not? Let's see. Stop it. And peer-to-peer.h. It seems I don't actually have a server. Oh, yeah, I do. Server. So my .c should be calling the server constructor, which I don't. Main. That might have been the problem. That seems better. Hey, there we go. Okay, okay. I think we're ready. Ready for the final reveal here. We've made it far. Debug. Delete all breakpoints. I print that the server is running, but I don't want to print this. Okay. So I think that will be what we have for today. So what we need to do in conclusion to set all of this up, as a user, I will need to define a peer-to-peer object and then call its user portal. User portal, you know, I wonder if we can actually, where is it? Peer.c. I wonder if I can, in fact, just call peer-to-peer user portal, passing it peer-to-peer. So if I do that, what I'm thinking is that we can, in fact, use this client function. The problem may have just been with the server setup that I didn't use its constructor. So let's launch this. Okay, that didn't quite work. printed server running infinitely. Why? Oh, this is the user portal. Okay. Client function. What I want to run, not user portal. That was recursive. Server is running. There we go. Okay. All right. We are just about at the finish line here, folks. Okay. So, I just need to find where it prints out here. There it is. I thought I deleted that, but okay. Okay. So what we have here is our basic peer-to-peer network. So we have an object that represents a peer-to-peer network that we create with this constructor. We pass in the global parameters for what domain, what interface, what service it's going to use, what port it's on. And we also pass it a server function and a client function. And these are defined by the user because I don't necessarily know what you want your peer-to-peer server to do, and I don't know what you want your peer-to-peer client to do. I happen to want it to make a chat bot for today, but in general, I don't know what it's supposed to do. So I let the user define what their server does and what their client does. And then they just need to create a peer-to-peer object and call its user portal, which is a name that will probably be changing in the near future. We run it. And then if I type something in over here, then it will send it to everybody that I already know. Okay, that's great. Now, this, in fact, is ready to work on in an actual use case. So what I'm going to do, well, I don't think I can because I need an IP address. But basically, I don't want to just give out my IP address for free on a public stream. That doesn't seem like a good idea. But this is basically our functionality. Let me add it to the Git repository. And that way you can check it and use it for whatever you want. And we're going to just say create the peer-to-peer object, and then let's add it. And let's push it to okay. So we have our peer-to-peer functionality. We have a very simple interface where we just define a main function that instantiates our peer-to-peer object with this handy constructor, and then we just launch it with this user portal. And the user portal is going to create a separate thread for the server functionality, and then it'll dedicate that main thread to our client functionality. And generally speaking, I think I will probably need to go back into this peer-to-peer user portal. And I know that it's going to start up this server thread, but as far as what it does, I don't think just calling the client function is sufficient. Probably what we'll want to do is include a set of other things for it to do. So maybe it would accept some arguments from the user. So you saw me using get here just a second ago, where I typed in get add dot or get push origin working. Whatever I type in there, it will actually do things in accordance with my commands. And it may be that sending a message is one of those things. So our user portal, we are going to kind of leave as this for now. It is just going to be calling this client function. The client function is just another infinite loop that takes input from the user and sends that to every single client that the user knows. Those are gathered from this server function, which every time it receives a connection, it will store it in a linked list, which allows it to send it to that connection later. And in the future, I'd like to make this a little more robust so that you can have different routes on the web server, and it will allow you to share maybe your list of hosts, for instance. My battery's about good here, so I'm going to turn the camera back on. And if you guys have any questions for me, I'm keeping my eye on the chat here. Not seeing anything just yet. There's also only one person here, so I don't know. Anyway, that is about it for today. I think our next steps are going to just be making the server function, client function more robust. And I'm going to spend some time on my own working on the peer-to-peer, getting it documented, naming things appropriately, and making it look nice. So I think that will do it for today. I am not seeing any incoming questions, so I'm going to assume that there are none, especially considering there's only one other person here. But I really appreciate that you joined me for this, and I think I will be doing more of these kind of streams in the future. So till next time, thank you for joining, and toodaloo.